What if I told you that scattered across our universe are stars that defy every rule of physics we thought was unbreakable? Stars so massive, so cold, or so ancient that they shouldn't exist at all. And yet they burn brightly, mocking everything we know about matter, time, and gravity. These are not just rare anomalies, they are cosmic mysteries rewriting the laws of the universe. This, the story of the impossible stars, beacons of light born from matter that should have collapsed, frozen, or never formed in the first place. Welcome to the greatest astrophysical puzzle of our time, the rulebook of stars in the vast cosmic theater. Stars are the main actors. They are born, they burn, and eventually they die. From the smallest red dwarf to the most ferocious supergiant, every star plays by a well-established set of rules we've spent centuries uncovering. According to our understanding, stars form when massive clouds of gas and dust collapse under their own gravity. This collapse generates intense heat and pressure at the core, igniting nuclear fusion, turning hydrogen into helium, and that fusion is what powers the star, balancing it against gravitational collapse. The star shines, lives out its life, and depending on its mass, ends in a predictable way. As a white dwarf, neutron star, or black hole, everything seems perfectly ordered. But what if the cosmos isn't playing fair? Because not all stars follow this tidy narrative. Some stars are far too massive to have formed naturally. Others are too cold, too old, or composed of materials that shouldn't exist in such abundance. They radiate strange elements, emit unexplainable energy bursts, or live in states that defy the known laws of physics. These stars shouldn't exist, not by the rules we know, but they do. And that's not just a scientific puzzle, it's a crisis of understanding. How can a star be older than the universe? How can something as chaotic as a neutron star survive inside another living star? Why are some stars so heavy they should have collapsed long ago, or so light and stable they escape expected death? Each discovery forces astrophysicists to revisit the very framework of stellar physics, to challenge Newton, Einstein, and even the Big Bang timeline itself. In this chapter, we lay the groundwork. We explore what stars should be, how they're supposed to form, and what makes them tick. Because once you know the rules, only then can you understand how utterly strange it is when those rules are broken. And as we move forward, you'll see that these impossible stars aren't just rare. They might be clues to an entirely new layer of reality. The Methuselah Star, older than time. Among the stars that challenge our understanding, one quietly sits just 190 light-years away, hidden in plain sight within our own galaxy. Its name is HD 140,283, but scientists gave it a much more provocative nickname, the Methuselah Star, named after the biblical figure who lived longer than anyone else. Why? Because this star appears to be older than the universe itself. You heard that right? According to precise measurements from the Hubble Space Telescope, this ancient star is estimated to be 14.5 billion years old. But our universe, the entire cosmos, is only 13.8 billion years old. That's a problem. A very big one. At first, astronomers thought it must be a measurement error. Maybe the data was off, or the models we used to calculate its age were flawed. But the more we refine the data, factoring in metallicity, brightness, distance, and stellar evolution, the numbers stayed stubborn. This star seemed to predate the universe. It was like finding a tree ring that dated back before the Earth itself formed. Something was deeply wrong or deeply misunderstood. The Methuselah Star is a low metallicity subgiant, meaning it formed early in the universe's history. For most of the heavy elements like iron or carbon were forged in supernova. Its chemistry tells a story of ancient birth. But even accounting for error margins, its age still grazes or exceeds the age of the universe. Some estimates place it at 14.27 billion years, just barely skimming under the cosmic limit. But that's assuming everything in the model is perfect, and we know it's not. So what does this mean? Is the universe older than we think? Could our understanding of the Big Bang be incomplete, or is there some exotic mechanism, maybe gravitational time dilation or dark energy, that's skewing our calculations? Some have even speculated the star could have formed in a pre-Big Bang environment or another bubble universe that merged with ours. Wild theories, yes, but when you have a star that shouldn't exist, every possibility is on the table. The Methuselah Star isn't just old, it's ancient beyond belief. And its existence cracks open one of the deepest mysteries in modern astronomy, that our cosmic clock may be ticking on a schedule we still don't fully understand. This star shouldn't be here, and yet it is. Burning silently, as if whispering a secret about time, space, and everything we thought we knew. Thorns that cow objects, hybrid monsters. Now imagine this. A star that shouldn't just be rare, but borderline impossible. A freak of cosmic nature that combines two dying stars into one living monstrosity. It's called a Thorn-Zit-Cow object. Part red supergiant, part neutron star, and completely bizarre. First proposed in the 1970s by physicist Kip Thorne and astronomer Anna Zitkow. These objects exist only in theory. Or so we thought. In concept, it's simple. A massive star goes supernova, leaving behind a neutron star. But instead of flying off into space, that neutron star crashes into another nearby star, burrowing deep into its core. The result? A star within a star, a fusion of death and life in a single smoldering body. Let's be clear, this should not happen easily. The gravitational chaos, the collision dynamics, the precise mass ratios required, it's a 1 in a billion scenario. And yet in 2014, scientists discovered a star in the Small Magellanic Cloud named HV 2112. Its chemical fingerprint was all wrong, enriched with elements like molybdenum in ways no normal star should have. These are the exact exotic byproducts predicted for a Thorne-Zitkow object. It wasn't confirmation, but it was close. Suddenly, the theoretical became possible, but even stranger is what lies at their core. A neutron star is one of the densest objects in the universe, so dense, in fact, that a teaspoon of its matter would weigh billions of tons. And in a Thorne-Zitkow object, that neutron star sits buried inside the outer layers of a swollen, dying supergiant. It continues to exist, compressed and suffocating, yet somehow stable. Fusion happens in layers around it, powered not just by normal hydrogen reactions, but by the chaotic mixing of nuclear matter with a neutron core. It's like Frankenstein's monster, but forged in a cosmic furnace. Survive. How long can they last? Are there more of them hidden across our galaxy disguised as ordinary red supergiants? The truth is we don't know. No telescope can peer deep enough into their core. But the chemical signatures, the mass anomalies, and the strange behavior of certain supergiants suggest these monsters may be lurking in plain sight, cosmic paradoxes defying both stellar evolution and common sense. If Thorne-Zitkow objects are real, and all signs say they might be, then the universe is capable of creating stars not just from birth, but from collision, decay, and death. These aren't just anomalies. They're warnings that our understanding of what stars are and what they can become is far from complete. Sometimes what seems like the end becomes something terrifyingly new. But when you have a star that shouldn't exist, every possibility is on the table. The Methuselah Star isn't just old, it's ancient beyond belief. And its existence cracks open one of the deepest mysteries in modern astronomy, that our cosmic clock may be ticking on a schedule we still don't fully understand. This star shouldn't be here, and yet it is. Burning silently, as if whispering a secret about time, space, and everything we thought we knew.